Well, the answer is this stuff, calculus, turns out to be as easy as riding a bike. So here's some continuous motion. I think you'll agree it's continuous motion. It's kind of scary. This is, if you haven't been to Edinburgh, this is Edinburgh in Scotland. And some really remarkable continuous motion. Okay, so that was continuous motion, right? Or was it? Well, let's go back and let's run through that again. And let's ask ourselves, what were we really seeing? Okay, so here we go. Continuous motion. Or was it? Were we looking at continuous motion, or were we actually looking at discrete motion? Discrete motion, discrete motion, discrete motion. Bit more discrete motion, whoops, stop, discrete. We weren't actually seeing continuous motion at all. Our mind, our cognitive system was being fooled because anything that moves by at 25 frames per second or more, the brain just sees as continuous motion. So look ahead, what you're seeing there is what we call a differential. There's a differential. The difference between one frame and another. In fact, the mathematics behind this, when we do it mathematically, is what's used in the encoding of videos, because in a video like this, you basically just need to encode the change because everything else is the same. So you can do with, you don't have to update the bits in the whole thing. So a lot of good video compression encoding makes use of the fact that you don't need to change things that aren't changing. Okay, so we weren't actually seeing continuous motion at all. We were seeing discrete motion. And that's the basis of calculus. That's differential calculus in action. Kind of amazing, actually. Yeah. Okay, I actually do have a mountain bike, and I've never even tried to do things like that. Okay, so that's calculus. That's differential calculus. Let's just see how it cashes out in this fashion. Because what you're going to see is just a symbolic version of what you've just seen. That continuous motion can be viewed in terms of a sequence of static images by looking at how one image changes to the next. And the process of going from one image to the next in differential calculus is what's known as the differential. Or taking the derivative tells you how things are changing. So just as the video compression can encode the image and then just code the information to generate the next image, so in calculus, the derivative can tell you how to take a snapshot and generate the next frame. The one difference between the two is that in a video, so long as you've got something that's moving at 25 frames a second or more, the cognitive system is fooled. It looks absolutely continuous. Well, you can't fool mathematical logic quite the same way. In calculus, the frame has to be frozen for an infinitesimal piece of time, and the film speed has to be moving infinitely. So you've got to have infinite speed of frames that are infinitesimally small. And that's what made it difficult to develop, because you have to do it with infinitesimals and infinite speeds in order to make it work in mathematics. Mathematics is a hard taskmaster, and 25 frames a second won't fool mathematics. It fools our brains, but it doesn't fool our mathematical brains.